So let's have a look at how to form equations. So here's our example. Mrs. Snedden is a fast walker. She can walk at a speed of around about 2 meters per second. So to do her duty at school, she walks a loop. If she starts her duty on the stairs 5 meters away from the maths commons, we want to create an equation to represent the distance that she travels doing her duty. And we want to explain this equation. So I'm going to draw a diagram to represent this. So she's going to start somewhere and she's going to do this loop. So that's where she would go to her loop. But remember, she's 5 meters away on the stairs. So there's that little starting distance there. So she's actually 5 meters away from the starting point. So we've got these two numbers. She walks at a speed of 2 meters per second, and that's going to be our gradient. That's how fast she walks. Then we've got this other number that she starts 5 meters away on the stairs. So that means she's got to walk 5 meters before she can make a start. So it's essentially she's 5 meters before the start line. So this is going to give me a y-intercept of -5. So now I'm going to write the equation, and the equation is to do with distance and time. So I can say, well, my distance that Miss Snedden travels is 2 times the number of seconds, 2 times her time, take away 5 meters from where she started. So there's this equation represented on the graph. And now we'll try a second example. So that was when I give you a word problem, you need to form an equation. Now it's forming an equation if I give you some information, some data. So here we've got two students, a 14-year-old who took 24 seconds in her wall sit time, or his wall sit time, and a 16-year-old student who was able to do the wall sit for 48 seconds. We want to make an equation connecting these data values. So the first thing we want to do is draw the coordinates into decimals and visualize that, see what the graph actually looks like, well, what the points look like. So that's what I've done first of all. Okay, I've put those coordinates in there, 14, 24 and 16, 48. The next step is to calculate the gradient. So I want to form a triangle and find the rise and run. So you'll notice I've zoomed in a bit more on the graph, and what I want to do now, my gradient is my rise over run. So I'm going to find out what is the rise for this situation, and that's going from 24 up to a value of 48. So my wall sit time, I'm rising up by 48, take away 24. So that's the difference. Then I've got to work out the run. So how much have I run along? And that's going from an age of 14 across to an age of 16. So that's a difference, 16 minus 14, it's a difference of 2 years. So we've got 24 divided by 2, our rise divided by our run. And that's going to give me a gradient of 12. Okay, so I have my gradient. Now I need to find the y-intercept. So to find the y-intercept, I'm first of all going to write down the general equation of a straight line. So y equals mx plus c. Then I'm going to substitute the gradient in because I've found the gradient already, so I'm going to put that information in the equation. So I write down the equation, and instead of m, I'm going to put the gradient of 12. The next thing I'm going to do is substitute one of the coordinate points, and I've chosen the coordinate 14, 24, and I'm going to substitute that into the equation. So remember, the value of 14 is my x coordinate, and my 24 is my y coordinate. We always write the coordinates x, y. So I'm going to write down everything except for the x and y, and I'm going to replace the y with the value of 24 and replace x with the value of 14. Now I'm going to do a bit of simplifying. So I'm going to do 12 times 14. So I'm leaving everything else alone. I'm just going to simplify 12 times 14, which is 168. Now what I want to do is rearrange, because I'm trying to solve this to find my y-intercept c. So I want to get c by itself, and I want to get all the other numbers to the other side of the equation. So the 24 is already on the left hand side, but the 168 isn't. So I want to move that 168 across. So I'm leaving the 24 on the left, I'm leaving the equals C on the right, and I'm just going to pick up that 168 and move it from one side to the other. And because I'm moving it across the equal sign, it changes to become negative 168. So my last step is to solve that. So I'm going to do 24 take away 168, and that's going to give me C equals negative 144. Okay, so now I want to put all of that information together and then explain it. So our wall-sit time is equal to our gradient, which is 12, times the age, because that's my x variable, take away the 144. So y equals mx plus c. Now we need to explain this. So I've got a gradient of 12. So a gradient of 12 means that as students get 1 year older, so their age increases by 1 year, the amount of time that they can do a wall sit for increases by 12 seconds. Remember, 12 we can do as 12 divided by 1. So that's why I say as the age increases by 1, the wall sit time increases by 12 seconds. Now we need to explain the y-intercept. And so we've got a y-intercept of negative 144. And that's for a student whose age is 0 years old. So remember, it's always when your x value is 0. So in this case, it's the age. So it's not possible to do a wall sit for negative 144 seconds. So in this case, it's another example where our y-intercept doesn't have any relevant meaning here.